forward, we are continuing with polynomials though, and this is where those letters are going to become more fun. I will tell you this. This is one of those moments though where we need to know how to do it, but make sure today we have an open mind with it. Please just kind of keep that in mind, take notes, ask questions, but don't act like you need to know it today. We'll practice this more. What I'm going to present today is one way to do it. As we move into later this week and next week, I'm going to present a different way of handling this, okay? So let's keep that in mind as I move forward. Now, with that said, though, the first thing that we want to talk about is the fact that we've been working with polynomials, right? And one of the things that we need to find when we're doing polynomials is intercepts. Now, hopefully, when you start looking at polynomials, as someone mentioned before, they had the degrees is one aspect, but you should also be looking at this like, hey, we know one intercept because of the constant term. I wrote G on the first one, sorry. So we can get one intercept by a quick glance, right? So remember we talked about how important making sure we see the leading term and the constant term in our polynomials can be as far as just getting information. And we're going to talk about how that's even important with the idea of factoring and getting to what we're going to call the quotient from a division standpoint, okay? With that said, though, what's the other way to find intercepts, right? So if this is my y-intercept, what do we do to find x-intercepts? Set it equal to 0, right? Now, this is one thing, though, that we had a new term for. Make sure you remember that you write this as the zeros of the function. And in this case, I just put it in terms of f, right? Zeros of whatever function we're working with. Make sure that you're careful with that, though, to get that new term out there, right? So if I tell you to find the zeros of the function, hey, set it equal to 0 and find all the solutions. If I tell you to find intercepts, what solutions do we disregard? For you, all right? Well, we still want the zeros of the function, but what type of solution can we get when solving polynomials that we're like, hey, this doesn't help me right now? Say it louder. What's the domain that we have for a polynomial? All real numbers. So what type of numbers do we want to work with? Yeah, so we want to work with real numbers. So make sure you're careful, though, in the terminology. Remember yesterday I said to find what? Intercepts, right? So when you're told to find intercepts, we only want real solutions. Does everyone follow that aspect? Moving forward, make sure you're careful, though, because I could say just find the zeros of the function, and that means make sure you state those complex ones too, because those are zeros of the function. However, the thing that we need to learn, though, or make sure to correlate is that, hey, whenever I have a complex number, it's a 0, but it's not something I worry about when it comes to graphing. Okay, so that's how we bring together the first part of the course when we were solving these equations with the functions now. That's where the word zeros come into play. Now, in order to get zeros, this is where our factoring skills need to be broadened. We were limited in how we can factor. Because with quadratics, yeah, we had the factoring and the quadratic formula, right? But if I give you a cubic, well, really the only things we have is factoring by grouping, if we can even do it. And then the other one would have been the binomial, right? One thing to make sure we remember is that, you know, x cubed, say x cubed minus 8. Make sure we go back and look at that. I think I mentioned it yesterday, but that'll be one thing to go back to that card that you should have had on the first test if you didn't. So what the factors of that look like, okay? And we'll talk about it when it comes up. But today I want to focus on the fact that, hey, sometimes we can factor, which we're going to practice with these two, all right? But moving forward, we're not always going to be able to factor. So we need to have another way to deal with it, hence why I brought long division. Once again, I'll give the disclaimer, though. Remember, as I said, that yes, we're going to need to know how to do long division, right? But that's not the only way that we'll have. So usually what I do is on the test, one problem will say use long division. The rest of the test can use the other way. So please keep that in mind. The reason we need long division, though, is it works all the time, where what we're going to call synthetic division only works in certain circumstances, okay? So moving forward, how would someone factor f of x? All right, so we have a quadratic trinomial, right? So, you know, if you like that little table that we've used in class, that's a great way to handle it. hopefully though, like as y'all are working on this, you realize you don't have to write this table out. That's just something that I've put into habit as far as just even from a teaching standpoint to make sure, hey, what do we do when we get completely stuck? Make sure you remember it's 3 terms. That's the key. All right, that's definitely the focus here. Now, when dealing with this, we want to do A times C, though, as mentioned. So it's going to give us what, 24? And then our B value is 10. Are there any factors that work here? All right, 6 and 4 work, right? In fact, we could just do 6 times 4 and 6 plus 4. Now, I don't want to spend time on the grouping aspect, but remember, this is where I would have said, hey, break up that 10x into 6x and 4x, and we could use grouping, okay? So if that's something you need, make sure you fill it in, but make sure you see here that what this is going to give us is 2 factors. And we know it's 2 factors again because of the degree of the polynomial is 2, right? That highest exponent. With that in place, my factors need to look something like this. Things to kind of help with double check. I messed something up, y'all. I know I need to figure out where this negative stuff goes. It's gonna look like that. I put the negative on the 3s. Everyone see that? Which means the 2 would need to be -2, right? Now, the grouping would have taken care of this. Please make sure you see the grouping would take care of this. Okay. The negative is important though, because that negative represents a reflection. So that's why we don't want to ignore it, okay? But hopefully you'll see there. Let's just do the grouping then, I guess, since I messed up the clear up. Everyone can see where I'm coming from. All right, so as I fill that in, make sure you see here that we could pull out a -3 on x on this first group. The second group, we could pull out a 4. Yeah, I was about to say I messed something up again, y'all. I was feeling good and I went and started off bad. Well, like I said, I was just talking about this too. Oh, so it should have been 4. So I was messing up a lot. So there's a good reason I went through and did this correctly. So I get for talking. As you've learned, I make mistakes too. That's the thing about math. No one does it perfectly. So now my focus here again was dealing with the fact that we can get it into a factored form. When we can't factor quadratic, so that's where stuff like completing square and the quadratic form come into place. Okay. I think we're good now. Everything looks better now. With that said, though, when we go to g of x, right, we're forced to use grouping in that one, right? So when we get over here, we have to see that when we're forced to use grouping, I have to be careful with how I handle it because we've learned from the equation standpoint that sometimes I can factor more and sometimes I can't. Okay. Because we have x cubed rather than x squared, one of my factors still has x squared in it, right? So hopefully you'll see here though, this one does happen to be a difference of squares because the square root of 4 is 2, right? But we do need to alternate the signs because it's a -4. And the only time we can do this is when it's subtraction. Now, hopefully you also saw from yesterday why factoring is important. Why do we like the factored form? So when I went yesterday, we can look at the last one that we graphed. Right? The factored form helps us identify the x-intercepts by just glances, right? Because the nice thing about having it to where it's just x in the front, we're going to be able to say, hey, -2, +2. But what was on one of these factors that we were able to use as well? the square, right? The exponent on a factor helped us talk about what we called was multiplicity. The multiplicity for the -2 was 2, whereas the +2, it only occurred one time. And that impacted the graph around that 0. Remember, I talked about how if we were able to zoom in, you could say, hey, that's an x squared graph, right? Looks like a parabola. Once we zoom out, oh, it's definitely not that. It just happened to follow that same pattern. Okay. The same thing is true over here where it occurred one time. It looks more linear when I zoom in. But again, it's not linear because that was just focused around one part of that entire graph. Okay. With that said, though, that's why we like the factor form. It does help with identifying the zeros, right? As well as the multiplicity of those zeros. Okay. However, especially with g of x here, if I change this 20 to say 16, we will no longer be able to factor this, right? Because if you go in there and look at it from that perspective, the first one wouldn't change. But the second one, instead of being x minus 5, would be x minus 4. And all of a sudden, these are no longer the same and we cannot go further. And this is the situation that we need to start working for is, hey, when the traditional things we've worked with so far don't work, what do I do instead? Well, guess what? What did I say we do instead? Long division. Okay. How do I set up long division? 2147. All right, but we remember this little division bar, right? We put the 32 on the outside, and we put the 2147 on the inside. This is one of the things that we don't do by hand very often because we can use a calculator, right? You can go put this in calculator right now and tell me what it's. The problem is the calculator is not going to tell you the remainder unless you remember how I showed you to change a decimal to a fraction, right? With that said, we need to know the algorithm. I'm not asking this for the answer. I'm asking this for the purpose of the algorithm. What do I do to divide this value? All right, why'd you pick 214? Does everyone hear that? We start by doing the division, right? The key is just look at 32 and think about how does 32 go into 2? No. Does it go into 21? No. Does it go to 214? Well, probably. Let's go see how many times, right? That's the key. Now, a calculator can be helpful here, right? If you do 214 divided by 32, you're probably going to get 6 point something. Now, we don't want decimals. What you're going to find here is it's probably helpful to have just kind of an idea of what the multiples of 32 are. All right, just to list out a few, right? What I did there is just, hey, take 32 and start adding 32s to it, right? Make sure you see here, this is 132, that's 2 of them, and so on. Your calculator, again, is definitely a useful tool here, right? This is how we handle dividing numbers. Now, what you're going to find is there's a little bit more guess and check here. Polynomials, there will not be as much guess and check. I will try to help ensure you with that one. There's not going to be really a guess and check situation. It's just remembering the pattern, right? My first step is to say 214 divided by 32. And make sure you see here, as I mentioned, 6 times is the closest we're going to get, right? So what we're going to do is put a 6, but we need to make sure to put that 6 over the 4, right? That's very important as place value matters, right? What we're saying is 32 goes into this at least 60 times. I have to do more work to see if it does more than 60, but right now we know it goes into it at least 60 times. And how did I know it's 60? Well, because we put it over the 4, which was in the tens place. Okay. With that said, as I move forward, what do I need to do with the 6? Yeah, we have to multiply, right? What is 6 times 32, right? So we divided, we multiply, and thankfully I had my list over here, right? So I made the list. If you use your calculator, that's perfectly fine too. Please make sure you understand. I just made a list for reference. Once I get here, though, what do? So we started by dividing, we multiplied, and now we need to subtract. And in this case, as mentioned, it'll be 214 minus 192, okay? I was about to say, yeah, we need to borrow from the 2, right? And what did you say to do next? Right, so the 7 matters. Right, the 7 definitely matters, right? So make sure we see there that the next step is to bring down. Now, make sure you see here, though, as you bring this down, this sets up our next step, right? We're going to do the whole process again. This is why we call it the division algorithm. We keep doing it until we know when to stop. All right? So how many times is 32 going to 227? Times, right? I have it written here 224, so that's nice. But again, if you use your calculator, just make sure to cut off the decimal, whatever numbers in the ones place is what you use. So here we would put a 7. Down here we'd put 224. But what happens here when I do the subtraction? Right? Why are we calling that a remainder, though? Nothing else can be brought down. 32 doesn't go into 3, right? The only option here is either call it a remainder or work with decimals. Did I tell us use decimals? No. So what we need to make sure to do is say, hey, I know that the quotient here is the 67. The remainder is 3. Okay. What we're going to find here, this is helpful because some of the things that we've used in the past can be built from this, right? So one way to look at this is like, hey, I can write this as a mixed number, 67 and 3 over 32. I didn't tell us to do that, but just kind of remember those things. One thing I will say is remember mixed numbers. When you say 67 and 3 over 32, what operation is implied? Not multiplication, addition, all right? It's 67 and a little bit more, right? That's why we use the word and. Okay, so make sure you see there that, like what we're saying is, hey, it goes into a 67 whole times plus this little bit more, okay? But the quotient and the remainder are definitely things we want to focus on, make sure we identify. So is there any questions with that algorithm, though, where we went through, we divided, we multiplied, we subtract, and we brought down to continue to do the process a second time? All right, so the one thing I will say is we move over to this problem, there's gonna be less guess and check. It's the same process, though. Same process, okay? So keep that in mind. That's what we're focusing on here. That's why I said just know we're gonna work on this more. It's not just today. But what do you think we need to do first? When we get a problem like this, well, if I'm telling us to divide, and on the test, I'll make sure to say divide using long division. No, don't factor, because my directions will say divide using long division. Now, understand, factoring would be our first step, right? Like if I told you to simplify this problem, you would factor to try to simplify. Please understand the division is going to be for a purpose, right? And as I've already mentioned, factoring doesn't always work, so that's another issue. But make sure you see here that the first thing we need to be doing is setting up the problem. We have to set up the problem first. Now, some things that have to be true here, make sure you have it in descending order. This is where we must have descending order. There is no ifs, ands, or buts about that. It has to be in descending order for it to work. Every term must be present in that process as well. Now, what was the first step that we said we need to do then? All right, so if I just kind of write out what we did before, what did that first D stand for up here? Divide, right? Now, what's happening here is, how in the world do we divide this, right? This is the part that we have to now define. How do I divide something when I'm trying to learn to divide something? But that's also where I go back to said, we don't have to deal with guess and check, right? What you're going to find here with polynomials, our focus becomes on working through the problem. And in order to do that, we have to eliminate the first terms. So what we want to do is say, hey, our first division here, so we're going to look at this as our first step, is going to be the first term on the inside divided by the first term on the outside. And we're going to find here, though, that even though we're ignoring the other terms, they'll be brought back into it as we go through the problem. Now, understand you could still get fractions and decimals here, but that's not something we're going to see often with what we're doing. Our focus is just being comfortable with the process. How do I divide this, though? Right, so we can do 2 into 8, which is 4. What do we do with the variables? All right, what is that called? Does anybody remember what this is called? Right, division is also quotient, right? So remember our quotient rule of exponents. I took out the x in the denominator, right? What did I do to the top? From the exponent, does everyone see that? So make sure you see here, that's not going to be just 4, but 4x. Now, what comes after the division, though? Multiplication, right? What am I multiplying? Make sure we go back here. As I did my division, I started by doing 32 into 214, right? We got to the 6. What did we multiply on that step? We did the multiplication of that 6 with the 32, right? So what we need to see here is that, hey, this is equivalent to the 6, right? Now, why am I putting this here, though? It's not the tens place here, right? But what's right below it? Right? So what do we call that when we have 4x and 6x? When I put them together, they're what? Like terms, right? So as we deal with this, we put it over our like terms, and now we need to move into the multiplication. Okay. Well, keep in mind, our multiplication is going to be with those things that we just used. First and foremost, our divisor, and secondly, that piece that we got from our division. So when we go on to that next step, what we want to do is say, hey, what is 4x times 2x plus 1? Well, how do we multiply that? Right? And that's where the second term comes into play, right? We ignored the plus 1, but guess what? The distribution brings it back into place. So we'll have what? 8x squared plus 4x. Make sure, again, when you write that over here, though, we're lining up our like terms. What do we notice about those 4 terms, though, that we just stacked up? The first 2 are exactly the same, though. Is that clear to everyone? What do we have to do to cancel them out, though? That's the part we have to remember. That's where our subtraction comes in. Now, we have to be careful here. We're not just subtracting a single term, but a polynomial, right? So technically speaking, I should have parentheses here. Which means, what do I need to do with the subtraction? Right? So the way that I like to handle that is say, go in there and show that you're changing your signs. So anytime I have a plus sign, I'll scratch out and put subtraction above it to show that, hey, I changed that for the subtraction. Now, handy here, I could use red right now, right? To show that I changed that for the subtraction. But we need the subtractions because at that point, as mentioned, that's where we ensure that those 2 cancel out. That's the whole focus of the division, is for that first term to drop out. Now, don't forget, though, we did have another term there, right? What are we putting the negative 4x with, though? Right? So we get negative 10x, right? When we bring those together. Does everyone see we're done with the first time through? We dealt with this, which will be our focus on polynomial division. That's gone because it's 0. Now we can bring this down. And how many terms do we have now?
2.
Still 2 terms, right? And guess what? Doesn't that match what we're dividing by? Okay. Where do I go now, though? That's 1 step done, right? And I can go do the second step through. Now, you don't have to write it as like, oh, I did 1 step, I'm doing the second step. Okay. But I'm just making sure to show where my work's coming from. But what you say? Yeah. So what do I need to divide here, though? All right. Why the negative 10x, y'all? What's special about it? But that's the leading term of that statement, right? Because it's in descending order, the first term is going to be my leading term, right? So that's why I said take the first term and divide it by the first term, right? Now, make sure you see here, yes, we ignored the 1 on that first step, but it gets brought in with the distribution, right? It does get brought back to what we need. So when I deal with this division here, we'll get what, -5 by itself? Where do I put the -5 though? Right above the other -5, right? What do we do with it? All right, we got, because it's what, -10x minus 5? What do we notice about that one before we do our subtraction? All right. That's definitely something we should watch for, right? Because the whole focus of this is to go in here and say, let's change those signs. So I changed my signs though, because we're doing what? Subtraction, right? Now our focus, make sure you see our focus is the first terms. That's the focus. So when I cross stuff out, I'll typically cross out the first term to say, hey, that did what it was supposed to. It just so happens, what's -5 plus 5? And 0, right? Now I write that 0 intentionally though, because what does that 0 represent now? Yeah, it's no remainder, right? So make sure you see here though, the next step then would be like, hey, my quotient is the 4x minus 5, and my remainder is 0. Once if you practice it, it's not that bad, but it boils down to practice. If you do not practice this, it's not fun. I can tell you that right now. It's one thing that, if anything you're learning from this course, is that when it comes to mathematics, especially college algebra, if you do not put in the time and effort to practice, there is no way you can learn. It comes through practice. This is what it boils down to. And this is one of those things that hopefully, as I mentioned, there wasn't any guessing in check. 2 goes into 8 4 times, right? That's something we should all be comfortable with, dealing with that aspect. The quotient rule, I've tried to review that a few times throughout the course. It's not something we use every day though, technically speaking, right? This is something more kind of we're reviewing for today. This is a review for division. So make sure if you're stuck on the quotient rule that you do what you need to get caught back up. And as you see, I'm going to practice it in class, so we'll be able to review it there as well.
Also, so the second, like original problem, the second term, like after the division sign, that always goes, no. Talk to 2x plus 1, that always goes, like, the second thing would always go on the outside.
Yeah. So that's our divisor. What we'll say is that's going to be our divisor, or we'll put the little lowercase d of x. Okay. This would then, our quotient we will put as q of x, because the big difference here is we're getting a function, right? 4x minus 5 is a linear function. Our remainder we'll put as r of x. And this will be typically like f of x or whatever function we're working with. Okay. Any questions I can clear before we do another example? Now, one question for you: how do you check your answer? What do you mean plug it back in? So we divided by 2x plus 1, and we got 4x minus 5 as our quotient. What can we do with them to check that we did the division correctly? Multiply them together, right? Put parentheses around them and multiply. If we do that multiplication, does this surprise us for what we just found? Isn't that the same exact thing we just divided into? Right? So on the test, I'd be something to remember that, hey, when I'm done with this, let me multiply and see what happens. Okay. Now, with that said, let's do another one. Hopefully you saw there with a remainder of 0, we found the factors of that problem. So if you go back and you're able to factor a problem, that's another way to kind of confirm your answers. Okay. What is someone doing first with this after you write down the problem itself? Yeah, we got to set it up, right? So what goes on the outside? We're putting our division symbol, and what goes on the inside?
The two x squared plus x.
All right, is everything in descending order here?
Yeah.
All right, and no, on the test, I'll mix it up, so be prepared to always double check. All right. With that said, what in the world did we do?
Divide two x squared.
All right,
by
so that's
x.
us saying, hey, I gotta do this probably twice, right? Typically, you can look at the degrees and kind of know, since I'm dividing by x plus 2, it's a linear, right? So degree 1. I'm dividing into a quadratic, which is degree 2, right? So that means I'm probably gonna go through this twice, right? You can kind of see as far as what's going on ahead of time. Now, if terms are missing or stuff zeroes out in a weird way, that's not always guaranteed. Please understand that, okay? Just kind of expect at most twice. With that said, though, what you say the first term was? All right.
Yeah, right, so which gives you-
All right, so this one's actually a little bit nicer, right? Because, hey, it's just gonna keep the 2. The key here to remember then is, hey, my quotient rule says get rid of this x and subtract it from that exponent up top, right? So it'll give me 2x. What do I do with the 2x though?
You do multiply it by.
Why are we putting it on top of the x though again? That's my like term. Well, hopefully what you're gonna see here is that it's a whole column of like terms. Every column better be like terms. As you can see there, all of those had just x on them, that entire column, right? It's very important. I know with long division, it's been so long that I remember learning this. I don't remember if the teacher ever explained it clearly. Like, how many of you remember that 6 was in the tens place because we put it over the tens place? Right? Those are things that we want to watch for, that as we deal with polynomials, we definitely need to remember, hey, I'm putting the 2x there because that's where the x's go. Right? With that said, though, as mentioned, we need to do the multiplication. So since we're doing polynomial division, what about the multiplication do I need to remember? Right? Which is going to result in distribution, right? All right, so as we look at this problem here, what about that is like confirmation? I did the right thing. Right, which means when I go to do the subtraction, it's gone, right? Just make sure you see there, be careful to change that sign. Have something in place to help you know that, like, I changed that plus sign on purpose because I distributed the
If we
subtraction.
don't, like, if we just, like, from that step to that step, if we just, like, completely, yeah, we just subtract it from the jump, you don't take points off, or you?
No, as long as you have the proper sign change taking place. The main thing is that you understand why you're changing the signs. Is that clear to everyone? I like to put it there and then, as you can see, intentionally change my signs so that you make sure to see, I didn't just change the signs for the fun of it. I'm changing the signs to make sure we subtract, right? So whatever you're comfortable with, as long as we're doing it correctly, it's fine, okay? I don't even think I necessarily would require this work over here. Technically speaking, some of you might be confident to do that division in your head. Now, like I said, you might get some fractions every now and then you got to deal with, but that's not going to be on the test. Just know that, okay? With that said, though, we did have confirmation. The first terms cancel out, right? And then we're left with what? Negative 3x minus 1. I brought down the 1, though, without saying it. Are we done?
No, you do the steps.
Yeah. Now, one thing to always pay attention is the degrees, right? Hey, I have a linear and a linear. I can do the division. If your exponent on the outside is bigger than what's on the inside, just stop, because it's not going to work. Okay, we don't want to leave an x in the denominator is the key. So when you set that up, if the x drops out, we're looking good, right? We're fine. Why did I say 2x? I'm sorry. Sorry. I was looking at the top. But hopefully you see there, hey, I was able to simplify this where the x isn't there anymore. So we're still okay. But if the x is left in the denominator, then hey, I didn't need to do that division. Okay. With that said, though, make sure you see here, we're putting the negative 3 at the top and we're going back to do that distribution. What do y'all notice about this distribution, though? Is it exactly the same? Oh. All right. The other one, it was exactly the same, right? That's not always going to be the case, though, because when I go through here, the first two were as they should be, but that second one's going to give me what, 5? What does that 5 represent again, though? That's our remainder, right? So we get our q of x is equal to 2x minus 3, and our remainder, or r of x, is going to be 5. Now, I'm using function notation because no, it's like with the quotient, we had 2x here, right? So it's a function. This other one is just 5, but that's because I divided by a linear. So we'll see that kind of pattern tomorrow and such. We'll make sure to do some that have, like, say, the 2x minus 3 is the remainder. That can happen.
So if we have like a negative, like, no, I'm not talking about like this problem. I'm talking about in general, like, if we have a problem that has a negative for the remainder, is that possible?
Yeah.
Oh,
Right, because all I have to do is change this to say minus 13, 2x squared plus x minus 13, and all of a sudden you're gonna have a negative 7 for the remainder. That is possible. Anything I could clear up with the second time through? Now, remember, to my focus today was introduction purposes, right? To make sure that we see the process. What I hope that you take from this is that the division algorithm that we've used in the past does not change, right? So that's why I focused on the steps here. It's the same steps that we're gonna do here. The thing that I feel is nicer about this, once you get over the variables and such, the thing that is nicer about it is going to be the way we do the division side. Yes, there's more steps because you got to distribute, subtract. There's stuff there that gets a little bit more involved. But that's not as much guess and check, right? You just simplify whatever it is, use it, move it forward. Okay. Any questions, though, that I can help someone feel better about? All right, well, that's all we have time for today. Know that this is where we're moving as we go forward. Have a good day.